Think about the last time you went looking for a single name in your phone's contacts. If you were just scrolling downward through that massive list by hand, it could take quite a while. But when you type that same name into the search bar, it appears in a fraction of a second. Your phone skips reading the whole list by using a specific architectural shortcut to find exactly what you need. To make that happen, engineers had to move past simple lists and design a more efficient way to organize data. We can visualize how this works by imagining a high-end coat check room built to hold 1,000,000 different coats. If the attendant had to walk the aisles and check every single hook until they found your specific jacket, the wait would take all night. In our better system, the process starts when you arrive. You give the attendant two things: the coat you want to store and a unique identifier, like your name. Instead of picking randomly, the attendant does a quick mental calculation based on your name, leading to a specific hook number, like 402. When you return and give your name, they run that exact same calculation, getting 402 again. They walk directly to that hook and hand you the coat. They never had to look at a single other item in the room. By translating the name of an item directly into its physical location, we make the act of searching unnecessary. In computer science, that mental math is a concept called a hash function. It's a mathematical scrambler. You feed it a word or a name, and it reliably spits out a specific numerical coordinate. That resulting number tells the computer the exact slot, or index, where that information belongs in its memory bank. This entire setup, the data, the unique names, and the math formula, is called a hash table. The power of a hash table is structural. Because the data's name is used to calculate its own address, the information effectively reveals its own location. But what happens if the math formula accidentally generates the same hook number for two different names? When two items end up in the same slot, it's called a collision. Back in the coat check room, the fix is simple. The attendant just ties a short string from the first coat down to the second one, so they both hang in the same spot. Computers use a method called chaining to link multiple pieces of data within one memory slot. To find an item, the computer checks the calculated slot's first entry. If it's not a match, it follows the chain to the next. Even if the computer has to check a few items along a chain, this structured system is still much more efficient than checking every item in the entire database from scratch. This leads to a level of efficiency that experts call constant time. This chart shows constant time means performance stays instant, no matter what. Programmers label this O of 1, taking one mathematical step to find an answer. Contrast that flat line with standard searching. As data grows, the time to find a specific item rises dramatically. Because hash tables use math to jump straight to the destination, retrieving a contact from a list of 10 people takes the exact same amount of time as retrieving one from a list of 10 billion. The next time your phone finds a contact the moment you type it, you're seeing a hash table at work. If you'd like to see more invisible technology explained simply, feel free to subscribe.